Okay, so we are looking at the difference between surjective, injective, and bijective. Okay, let's start with what a surjective function would look like. So if we have our x and our y domain and our codomain, a surjective function would have all of y being mapped to. So if we have x, go to y, x go to y, x go to y, and we have one more x, go to y. This function right now is surjective because all of y has been mapped to. Now, even if we have, we'll go from a new one, we'll go over here. Even if some of them have more than one mapping, 2, 3, 4, what have you, it is still surjective as long as it's all mapped to in y. Now, as soon as we have one pop up over here, it is no longer surjective because it's free, it's been left alone. Now, if we, for an injective function, injective, we'll have our x again and our y, our domain, and our codomain. An injective function would have y being mapped to no more than once. A y value would be mapped to no more than once, if at all. Does not have to be mapped to. So we have x, go y, x, go y, x, go to y. We have one more x going to y. Now, this is an injective function because all of y has been mapped to, not necessarily all of it, because our y values have been mapped to no more than once. As soon as we have this one here, it's still injective because it doesn't need to be mapped to, as long as nothing has more than one connection, one more mapping. Now if we add another one over this side and bring it over here, it is no longer injective because this one here has more than two mappings. It has been connected to more than once, and you can't have that for an injective function. Rip that one off. Now for a bijective, so we'll do the same. We'll have our, let's move that focus up, we'll have x and our y, and our x domain, codomain. Our bijective function would have our mapping be equal to a surjective and injective function, so that basically all y will be mapped to, but no y value will have more than one mappings to it. So if we draw it out, we'll have x and x to y, x to y, and we'll chuck that one up here, go x to y. Okay, so this is bijective because all of y has a mapping to it, and no y has been mapped to more than once, say 2, 3, 4 times, whatever. But as soon as you have another x over here connected to that, it is no longer bijective because it is no longer injective. So it is only surjective given that they're all mapped to, but mapped to, one of them to be mapped to more than once. If we cross that out, ignore that connection. If we bring it back to a bijective state and add a y over here, it is no longer bijective because it is no longer surjective because we have y that has been left out of the connection, out of the loop, and it is only injective because we have a y that's been mapped to less than once. Okay, now let's do some examples. We'll just do some easy examples to keep the video short, comprehensive though. So we'll have 2 times x plus 1, so yeah, y equals 2 times x plus 1, so we'll have 0, 2 times 0 plus 1 equals 1, and we'll have 2 times 1 plus 1 will equal 3. Yeah, and so on. We'll just do one more. We'll go 2 times, we'll keep it going 2 times 2 in order, plus 1, which will equal 5. Now, if you keep looking at our outputs, or our y outputs, we can see that we're missing some numbers. We're missing a 2, and we're also missing a 4. If we keep going on, we'll see that you'll be missing more and more numbers. This is starting to look a bit like an injective function. So if we map out this, so if we have our x and our y, we can have, see, with our, this one, our 0, going to our y of 1. And we can see our x of 1 going to a y of 3. And we can have our 2, x of 2, going to a y of 5. So my hand's probably in the way. But if we look at the rest of our outputs that we're missing, we've also got a 2, that's our 2, and this one is our 4. This is an injective function because we're not going to have these numbers repeated again in our sequence. So no double ups, and we're also missing some connections, some mappings. If we did have a example that had these connected, then we'd have a bijective, but we don't. We have an injective function here. 2 times x plus 1 is injective. Do one more example. I'll try and get maybe a bijective one, something simple. Can't get much simpler than y equals x plus 1, and we're working with real numbers here. So from the set R. So we have x plus 1, so 0 plus 1 equals 1. 1 plus 1 equals 2. I won't do the rest, 3, 4, 5, and so on that way too. Keep that in mind, because that's also going to be keeping us surjective if they're all mapped to that way and that way. I will draw it out. I think there's space to do it over here. So we have our x and our y domain and codomain. So we have our 0 to 1, 0 to 1, 0 to 1, and we have our 1 to 2, 1 to 2, and we'd have our 3 to and so on. This will be bijective because it will keep going on for each one that goes down here, and it's always going to be surjective because we're not going to miss any numbers going forward or back, because all we're doing is passing 1 to x, and we can just move x around to give us every single real number. Now this is bijective. A surjective function would have us with a function up here that would somehow give us x values doubling up on the y values, so that, let's use this one here, but we'd have extra ones going over to here, and so forth. And that is injective, bijective, and surjective functions.